Charcoal is one of those materials that feels both ancient and modern at the same time. We see it today in barbecues, art studios, medicine, and even in high-tech filters. But long before it was a bag of black chunks at the supermarket, charcoal was a revolutionary substance that powered civilizations. To understand how charcoal is made, we need to travel through history, science, and the fascinating process that transforms ordinary wood into a powerful and versatile material. At its core, charcoal is simply wood that has been heated in the absence of enough oxygen to allow it to fully burn. This process, called pyrolysis, drives off moisture, tar, and volatile gases, leaving behind almost pure carbon. Think of it as cooking the wood rather than burning it. When wood is set on fire in open air, it combusts completely into ash and smoke. But when it is carefully heated with little oxygen, the fire can't consume it entirely. Instead, the chemical compounds break down, and what's left is a lightweight black carbon-rich substance that burns hotter and cleaner than wood itself. This is the secret that made charcoal invaluable to ancient blacksmiths, metal workers, and eventually to the everyday cook. Historically, people discovered charcoal thousands of years ago, likely by accident. Imagine early humans building a fire inside a pit and covering it with soil or stones. After the flames died down, they might return to find blackened chunks of half-burned wood. These chunks, when reignited, burned longer and hotter than regular wood. Over time, societies learned to intentionally produce charcoal by covering wood piles with earth or clay and letting them smolder for days. This traditional method, known as a charcoal pit or charcoal kiln, was practiced for centuries and can still be seen in parts of the world today. Now let's look more closely at the process. Making charcoal starts with choosing the right wood. Hardwoods, such as oak, beech, hickory, and maple, are often preferred because they produce dense, high-quality charcoal with long burning times. Softwoods like pine can be used, but they generally produce charcoal that burns faster and creates more smoke due to the higher resin content. Once the wood is selected, it is cut into manageable pieces and stacked in a mound or placed in a kiln. In traditional earth mound methods, the pile of wood would be covered with grass, leaves, and soil, leaving just a few small air vents. These vents allowed a controlled, slow-burning process. The wood inside would be heated by fire from the outside layers, but because oxygen was restricted, it would carbonize instead of turning completely to ash. Inside the pile, something fascinating happens. As the wood heats up to temperatures between 400 and 700 degrees Celsius, chemical reactions begin. Water vapor is released first, since fresh wood can contain up to 50% moisture. Then, as the heat increases, volatile organic compounds like acetic acid, methanol, and tar vapors escape. In traditional methods, much of this escapes into the air as thick white smoke. What remains inside the mound after several days of controlled smoldering is charcoal, light, porous, and nearly pure carbon. Once the mound has finished burning, the vents are closed completely to suffocate any remaining fire. After cooling, the charcoal can be dug out, crushed, and sorted for use. Modern methods of making charcoal are more efficient and environmentally friendly. Instead of smoky earth pits, many producers now use retorts or metal kilns. A retort is essentially a sealed steel container, where wood is loaded and then heated externally. Because the gases released during pyrolysis can themselves be burned as fuel, modern retorts recycle these gases to sustain the process. This not only reduces pollution, but also saves energy. In industrial settings, large-scale continuous retorts can produce charcoal much faster and with better consistency. The byproducts like wood vinegar, tar, and methanol are also captured and used in industries ranging from agriculture to chemicals. The physical properties of charcoal are what make it so useful. Unlike raw wood, charcoal burns at a much higher temperature and with less smoke, which is why it was historically vital in smelting metals like iron. Wood alone could not reach the temperatures needed to reduce iron ore into workable metal, but charcoal could. This ability to produce and sustain high heat changed human history, enabling the production of tools, weapons, and machines. Later, when coal and coke took over industrial roles, charcoal found new uses in households and science. Today, the charcoal most people are familiar with is charcoal briquettes. These are made not just from natural lump charcoal, but also from charcoal dust mixed with binders like starch, along with additives that control burn speed. Briquettes are uniform in shape and easy to ignite, making them popular for barbecuing around the world. But charcoal isn't only about cooking and heating. Because of its porous structure, it has a remarkable ability to absorb impurities. This makes it useful in water filters, gas masks, and even medicine, where activated charcoal is used to treat poisoning by binding toxins in the stomach. Activated charcoal is made by heating charcoal further with steam or chemicals to increase its surface area dramatically, giving it extraordinary absorption properties. From ancient fire pits to modern laboratories, charcoal's journey shows how a simple process can yield an endlessly versatile material. Of course, making charcoal also has an environmental side to consider. Traditional charcoal production, especially in developing countries, has contributed to deforestation and air pollution. This is why modern techniques that use waste wood, crop residues, or efficient kilns are so important. Sustainable forestry and innovations in biochar, charcoal made specifically to enrich soil and capture carbon, show how this ancient technology can be adapted for modern challenges. Biochar, for instance, is being studied as a way to combat climate change by locking carbon into the ground instead of letting it escape into the atmosphere. So the next time you see a piece of charcoal glowing on a grill, think of the long journey behind it. Charcoal is far more than just burnt wood. It's a material that has shaped human civilization for thousands of years and continues to play an important role in our daily lives. Thank you for watching. If you enjoyed uncovering the hidden stories behind everyday things, don't forget to like, share, and subscribe to Janosco. Hit the bell so you never miss a new discovery. Until next time, keep exploring the world's surprising backstories.